In this video, you might be puzzled by the title and by what you're seeing on the screen right now. The title said we were going to take a look at the interior angles of a circle, and here there's no circle in the picture. So what's this all about? So let me start you off without a circle. Taking a look at a triangle with an exterior angle. One fact that you may remember from the fall is that the exterior angle will always be equal to the two remote interior angles added together. So 55 and 20 make 75. And that'll be true no matter how I take this triangle here and change it. So if I have a 27-degree angle here and a 75-degree angle here, 75 and 27 add together to make 102. So what's going on and why is it always true? Well, if you recall, these two angles here are called, well, you can remember for yourself. These two angles are called linear angles, and they add up to 180 degrees. So this is the missing angle here that would make this one add up to 180 degrees. Now, in a triangle, there's also 180 degrees. So these two angles added together with this missing piece here would also have to make 180 degrees. Since they both share that same missing link, you could actually prove that this angle here, and we've done it before in the fall, is equal to those two together. That's a fact that I want you to remember as we move on to looking at an example with circles. So let me just open up. As you can hear, someone's chopping down a tree outside. All right, so this is the same diagram, basically, but I included a circle around the triangle. And let's take a look at that fact again, that if I change the angle here, no matter how I change the angle, these two remote interiors add together to be equal to the exterior angle. So let me add on a few extra facts here. So what do we know about the picture that's guaranteed to be true? We know that the exterior angle equals the two angles that are here, the remote interiors. We also know something about angle B. Angle B is half as much as the arc that's formed by D to C. So this arc right here, we call that X amount of degrees. We know that angle B is worth half as much as X. And the same thing we know about, a similar thing we know about angle C. We know that angle C is half as big as the arc that's over here from F to B. So these are guaranteed facts that we know are true. Just check them off if you agree with me. So how do we actually take these pieces and mix them together? Well, take a look at what I did here with this first line and this fourth line right here. I replaced angle B with half of X, and I replaced angle C with half of Y. And if you remember, that's called the substitution method. And that's basically our formula, the new formula for today. But I'm rearranging it so that you can remember it a little bit more easily, and then also be able to work with it better. So I could take this half that's in both of these terms here and factor it out. So this would be true. And I could also rearrange that as saying X plus Y divided by 2. And that's a nice, very convenient formula to help us remember how to find the measurement of an interior angle, which I haven't even mentioned yet what an interior angle is. An interior angle is formed when two chords or two segments that stretch from the circle back onto the circle. When those two chords intersect, they form four interior angles. The interior angle does not have to be at the center of the circle. In fact, many times they're not. So in order to figure out how big this angle is, the formula that you maybe have just discovered for the first time is to figure out the interior angle, you just add together the two arcs that the angle opens into and divide by 2. In other words, well, what else is that? What else is that referred to when you add two numbers together and divide by 2? If you bowl 2 games, you bowl 100 the first time and you bowl 200 the second time, add your scores together and divide by 2 and you get your bowling average. So to find the measurement of an interior angle, all it is adding together these two numbers and dividing by 2, or just say average the arcs together. Now you don't have to actually do all this thinking every single time, and that's the beauty of actually having this laid out as a formula for ourselves to follow, because all we do have to remember is to average the arcs. So here are a few more examples, or 2 examples for you to help you along since you're new at this. Looking at question number 1, they're telling us that AC, the measure of arc AC is worth 87 degrees, and the measure of arc BD is 35 degrees. And in the question, we're looking for the measurement of CEA. So C to E to A is the angle that we're after. And again, that's an interior angle formed by 2 chords intersecting. Now, before we even actually apply that new formula, let's take a look at these choices here and see if we can eliminate ones that obviously look wrong. Well, is this angle here 87 degrees? 87 degrees is practically a right angle. So I would say that there's no chance that that's 90 degrees right there just by looks alone. In fact, if you did draw in the central angle from A to C and O, that angle there would be 87. So this is definitely smaller. It's moved back and it's tighter than this angle that could be drawn. So I could eliminate that as one of the choices. And then probably thinking about what angles look like, in particular a 45 degree angle, which is half of a right angle. Based on just that alone, when I look at these choices here, I feel pretty confident in saying it's probably not 26. So it's probably more than 45 and looks to be definitely less than 90. Besides that, I think it's kind of risky to maybe start crossing out other things. So how do we apply the new formula to this? So we begin by taking that formula, which is to take 2 numbers, add them together, and divide by 2, or in other words, the average of the 2. So we're going to average the 87 degrees along with the 35 degrees. So add them together to make 122, and then divide by 2 to get 61 degrees. And the answer looks right in the picture as well. So that's something that I don't want you to move on, more quickly through this than you have to, is take a look at that answer. So 61 degrees seems to be a pretty nice looking answer there. And remember that its other matching vertical angle would also be worth 61 degrees. All right, moving on to one more example. For question number 2, just a little bit different than the last one. We still have an intersection of 2 chords, and they are giving us an interior angle, and they're giving us an arc. They're asking us to figure out the amount of degrees in arc dB. So we're looking at dB as what we're trying to figure out. So in this case here, we're going to apply the formula, but in a slightly different way. Again, before we actually use the formula, let's take a look at the choices and see which ones maybe jump off the page as being probably wrong. Well, a semicircle contains 180 degrees for each half of its arc. So right off the bat, this green arc right here is probably not 108 degrees. 108 degrees would make up more than quarter of the circle. So this would be 108 degrees, perhaps something like that. And it's probably also not something as small as 14 degrees either. I mean, 14 degrees of the circle would only amount to just a tiny bit like this. Now, that's not exactly 100% guaranteed to be correct by crossing those out, but right off the bat, I'm feeling pretty confident that these are drawn pretty much to scale. So it's down to either choice 2 or choice 3. And there are a couple ways to work this problem out. So we know that the 58 degrees is equal to the average of the blue arc and the green arc. So we're going to write 72 degrees plus that missing green arc, which I'm going to call x. Now I've got a formula to solve. I've got to find a way to get rid of dividing by 2 in my equation. To get rid of dividing by 2, I do the opposite, which is multiply by 2, which will quickly change the equation to get rid of the fraction, giving me 116 is equal to 72 plus that green x, which we're looking for. And then just getting x by itself will get me to my answer. As you can hear someone chop down the tree perhaps in the background. Maybe they're sawing some wood. So we got 44 degrees is equal to x. Now it's one of the choices, which is very good. And the answer takes, when I take a second peek at the picture, I can tell that this is actually a good answer because it does actually look slightly smaller than the 72 degrees for the blue arc. Now another way to solve the same question, which is maybe the easier way to do it, is just to think of that interior angle as being exactly halfway in between the blue and the green angle. So if I didn't know that that was 44, if I didn't know the green was 44 yet, and I know that that blue arc is 72, the 72 is actually, 14 degrees more than the interior angle. So if that angle 58 is going to be exactly halfway between the blue and the green, I'm going to have to subtract 14 degrees to get the green arc as well, which would bring me to 44. So that 58 has got to be exactly halfway between the blue and the green, and that's just another way to solve this particular question. So after all this, got a few questions for you to practice, and if you don't have the worksheet, I'm just going to show you the questions so you can maybe take a screenshot, or if you don't have the worksheet at all, you could still work on these questions. These are questions looks like they came right off the Regents exam. So there might be about a dozen questions here for you to practice. In some cases, we're looking for the missing angle. In some cases, we're looking for the missing arc. But it'll give you an opportunity to practice working with the formula. Here's some work with algebra as well, solving for x. And I believe that's about it. Yeah. All right, other than that, have a nice day.